Welcome back to calculus. You guys did wonderful on your last test, so let's see how you guys do in your next one. What we're going to do is we're going to start off this section of lessons of 1.4, fitting models to data. Now, at the end of this, you're going to be able to both use a linear model to plot a real-life data set and use a quadratic model to plot a real-life data set. You will be doing both of these with a graphing calculator. So, if you don't have a graphing calculator or a graphing calculator program, you are definitely going to need one to do this stuff. I'm going to show you, walk you through everything you need to know how to do. So let's start. First thing, what is mathematical modeling? Ready? We're going to do what we did before. When I point to the camera, you're just going to yell at your answer, even though you're by yourself or with a friend. Just good to try to get the right answer. If you get it wrong, no one's going to know, really, unless you're with your friend. All right, so first one, applying mathematical skills to obtain answers, and what type of problems do you think you use modeling for? If you said real problems, you are correct. So like in real life problems. You're going to learn how to apply mathematical skills is blank from learning math itself. So applying the skills is, did you say different from the actual learning the math itself? So you learn a lot of math, but actually learning how to apply this math is what makes you go to the next level, which is where we're gearing to go up to. It's used in a wide range of blanks, some of which blank appear to be mathematical. Right? Let's go again. Used in a wide range of, did you say applications? Some of which blank appear to be mathematical. Don't or do not appear to be mathematical. So you may not even know you're using math, but you're really using it. Modeling also allows quick and cheap evaluations of blank, leading to optimal solutions. Quicker, cheap evaluations of, did you say alternatives or any synonym of alternatives, leading to optimal solutions. There are no precise rules and no blank answers. Begins with an R. Right or correct answers, or C, either one. It can be learned only by doing, right? So there is mathematical modeling for you, all right? So, ready to go to step 2? Now, first thing we're going to do, we're going to fit linear models to data. A linear function. The word linear means what? Line. Do you remember what a linear function looks like? If you said y equals mx plus b, you just did this not too long ago. You put it in slope-intercept form. All right. Now, there's something we need to know, though. There's something very important about this. There is a little letter called R. Now, R is, I don't expect you guys to get this, it's the correlation coefficient. Okay, why is it called R? I mean, if not C. Well, C is used up for something else. C is the natural constant, so you can't use C twice. Now, what the correlation coefficient is the strength, it's like a vector almost, the strength and direction of a blank relationship between two variables. Linear relationship. So R has to be between two numbers. It has to be between -1 and +1. Now here's how this works. When it's -1 or +1, how many of the points do you think are actually on that line? So it's almost like you draw a scatter plot, you draw a line through the scatter plot, and the R tells you pretty much, you can use it to find the percent of points on the line. So if it's -1 or 1, just those two, blank with the points on the line. You said all, you are correct. When R is 0, how many points do you think are on there? None. Okay? It's just a weird looking plots all over the place. When R is, now this isn't a point, this is between -1 and 0, not including the 2, or between 0 and -1, blank of the points are on line. So not all, not none, but some. Okay? Now, here's how this works. If R is negative, your graph is going to be going down, like a negative slope. If R is positive, your graph is going to be going up as a slope. And you can go anywhere from 0.00000, tons of zeros and a 1, all the way up to -1, and then infinite number of zeros, 1 to 1, right? Now, R squared, that's how you actually find the percentage points on the line. So, and then the slope determines the sine of R. So what you do is whatever R is between 0 and -1, you're going to square it and then multiply it by 100. And there you go. And that gives you the percentage of points on the line. The slope determines the sine of R. So like I said, if it's negative, your line's going down. If it's positive, line's going up. So what you guys do is for 1 through 4, I want you to actually take those points, try to estimate, I know, guesstimate, whatever you want to call it, what r is here, and then the r squared, what percentage of the lines are on the point. All right? So you can draw a line through there and just look and guess, okay? If you're off by 20%, that's fine. All right, hopefully you're done. Problem number 1. Well, this line goes straight through everything, and what kind of slope does it have? It has a positive slope because it's going up. So, positive 1. Now, what is 1 squared? 1 times 100 is 100%. All right, 2. The line, once again, goes through everything, and it's going down now. So that means it has a negative slope. Since all the points are on the line, it's negative 1. Negative 1 squared is 1, and 1 times 100 is 100%. See, percentage of points on the line, this is your R. All right? This one. All right, we draw a little line through here. About how many of these points are on the line? Or close to 1? What do you think? Give me a number. Yell it out. Did you say about, well, we're always going up, so it's positive, right? What number of points? This is about 0.7-ish. That's what I got for my R. So about how many points are on the line? On 1, 2, 3, 4. On 1, 2, 3, 4, 5-ish off. All right. What's 7 squared? 49, right? 49 times 100 is 49%. All right. Not too bad. What about this one? Is it positive or negative? Is the line going to go up through here, down through here? What do you think? Up, right? Because that's we connect 3. But I can also go down. So which one is it? What do you think? The answer is 0. Okay, there is no correlation here. You don't know how to do this line. I can draw this line going across here, like this. You still have equal points across from equal lines. Right? Now, what I'm going to do is, I'm going to teach you how to find a linear equation using a graphing calculator. All right? Now, I'm going to go get my graphing calculator real quick. All right, so I got my little calculator right here. And I'm going to plug this in, and it's going to magically pop onto that equation. So first thing, linear function. It says, linear function is y equals mx plus b. And we're just going to worry about the r's. So, to input the points, first thing you're going to do is, you have to find out what your points are, from what to what. So you're going to input all your points. Now you're going to get a bunch of points here. And when you get a bunch of these points, what's going to happen is, you're going to have to input them in. So they're your x, y points. This is your x, this is your y. So what you're going to do is, you have to first, before you do anything on these calculators, it's very important, you click the memory button, and then you're going to reset all the memory, okay? Now, once you reset it all, you're good to go. The reason you're going to reset all the memory is you don't want old lists in there. Now you're going to click on Stat, okay? You're going to click the Enter button because you're going to go to Edit, all right? And then this is going to be your X values right here, and these are your Y values. So for instance, the first point I put in was 3, 6. Then I put in 0.6, what am I put in? 6, 14, okay? So then you can, doesn't matter what order you do, but these are your X's, these are your Y's. You have to make sure they correspond, okay? And then once you get them in, these are your inputting points, okay? You can go back and you can change them if you want. You can delete them if you want. You just got to make sure they match. Now, next thing, to find the least square regression line, you go hit StatCalc. So Stat, you go over one to Calc. Okay, you just click Enter through all those, and then you get your linear regression line. Now your A is right here. So this would be y equals 2.333x plus the 6 stuff. All right. Now, another thing you can do to find your R, you hit the Variance button. You go over to Stat, then you go over to EQ, and you go down to R, which is number 7. Hit Enter, and then it gives you your stat, 0.996615. All right, so that's pretty much how you use the calculator. You can also graph if you need to. The graphing buttons are right here. You can play around with them if you want. Pretty much what you're going to do is you just got to turn your stat plot on, okay? And then afterwards, you want to maybe set your domain and range just to make sure everything's good. And then you hit the graph button and it graphs it. All right? Now, the best way to do this is probably with an example. So what we're going to do now is we're going to try an example. Oops. Where's my button at? I'm moving too fast. All right, so we're going to try example number 5. All right, sorry. Computer gets a little laggy with our calculator. A class of 28 people are collecting the following data, which represents heights and arm spans. So, this is a graph right here. This is your heights. This is your arm span in inches. So, all you're going to do, ready? And I want you to do this along with me, the first one. Eventually, I'm just going to get right to the answer. So, first thing what you do is know that your first column is L1, that's your X. Your second column is L2. So, the first thing you have to do is we're going to type everything into our calculator. Okay, now do you remember just how to do that? Hopefully you do. You're going to hit the stat button, and then you're going to hit the edit button. So the stat button's right here. You touch the stat button, and then after you hit stat, you hit edit. Now, L1, L2. So I'm going to type in 60, 61. Then I go, okay, then I'm going to go 65, 65. It doesn't matter what order you do it, as long as your red ones right here in the first column, those are your L1s, your L2s, the other ones. So 68, 67. And you're going to type all these in. So type all those in real quick. I just got 2. Be right back. You should still be typing those guys in right now. All right, so we have 62, 60, 65, 65. So look, as you can see, this does take some time. As you're doing, I'm just going to explain some things to you. You have to be very careful when you're typing all this stuff in. All right? Now, when you do it, if you want to do the whole first column first, 60, 65, 68, 72, type them all in, and then do the second column, you can. But what I suggest doing is just every once in a while check to make sure your numbers match up. Okay? Because it's very easy just to skip one number and then have everything go crazy. Because if you mess up one of these, you're messed up. Also, what I would do too is I would always check these just to make sure the numbers look right. Because sometimes what happens is you forget to press enter on the calculator. And instead of pressing like 68, enter 70, you'll do 6,870. So it's good, that's another quick check. All right, also make sure if you're using decimals, your decimals are in the right place. But a lot of times just checking really quickly isn't too bad. But as you can see, typing in something like this is the longest one we're gonna do. Does take a while, okay? So there's 1, 2, 3, 4, 5, 6, 7. 7 times 4 is 28. So you're also going to want to make sure that this number right here tells you how many entries you have. You want to make sure that ends up with 28. If you end up with 27, it means you missed one. If you end up with 29, it means you entered too many. And this graph right here is just class 28 people collecting data, represents their height. You're just doing height to arm span. So a lot of times when you do these graphs, what you're doing is you actually take data that was collected by a scientist or an intern or something, and you do this science. So, as you can see right here, you went through, we checked it all. Those are all your L2s, those are all your L1s. I go, okay, that looks pretty good. I have my number 28, so now I can go to my next one, least squared regression line. So I hit stat, I hit calc, okay? And then what you want to do is stat, calc, and then you're going to go down to number 4, which is lin reg, and then you just click down to calculate. Sometimes some calculators do it automatically, and just so you know, here A is 1, point that, B is negative that. So this is going to be going next to your X. So just pause this real quick. All right, so Y equals 1.006, X plus negative 2. Oh no, you reset this. All right, now the regression coefficient. Sorry. Oh, should be able to drag this guy right here. There you go. All right, so now when you get your linear, this goes next to your x, this is your y-intercept. All right, now for the regression coefficient, what you're going to do is, the next part, you're going to type in vars, which is right here. You're going to go down to 5, which is stats. You're going to go down to number 7 after you go 2 over, 2 over, down to 7, which is r, and then you're going to type it in. Now that is your r. You want to take it to at least 3 significant figures. The more you take it to, the more accurate it becomes. So in this case, I'm going to just take it to 4. Because this is a 9, I round up, 0.9725. If I wanted to find the percentage, I would just square it. Okay, that's it. Pretty easy. Now, if I want to find the slope from the graph, I want to go a little bit more advanced. What you're going to do is you would pick 2 points on the graph. Very simple. I like to pick points that fall right on numbers, so I pick 62, 62. And I also pick this number right here, which happens to be 70, 70. Now, do you guys remember the slope formula from last week, 2 weeks ago? y2 minus y1, 70 minus 62, over x2 minus x1, 70 minus 62. Now that becomes 8 over 8, which is 1. Does that look like it has a slope of about 1? Yes. And guess what? R, which is my slope, is about 1. So as you can see, this is a little bit more precise. This is a little bit less precise. But you can still estimate your answers. Got it? All right. Let's look at number 6. Now we're going to start flying through these because you know what to do. So for number 6, the first thing we're going to do is, you know that L1 is your T, L2 is your S. So pretty much is L2, your speed is dependent. So it's like independent dependent like we did with the other stuff. So what happens here is whatever you plug in for T gives you your speed. All right? So how does this work? All right, so you can type in 0, 2, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 11, and you don't have to put 11.0, you can just put 11, 19.4, 29.2, and 39.4. Least square regression line, you're going to hit, once again, stat. You're going to go to edit, number 1, and then you're going to go to linreg, and you get an answer, number 4, sorry, I did it wrong, of A is 9.7, B is 0.04, so it's 9.7t, which is your x, plus 0.4. All right, now next one, regression coefficient. You hit vars, all right, number 5 stat, click over to the EQ, you go down to number 7, and as an answer you should get 0.99331. I went to 4 significant figures, just try to be a little accurate. All right, what would the speed be after 2.5 seconds? So now, how do we do that? We don't got 2.5 here, but what did we just create? We created an equation, okay? So we're going to use this equation right here that we created, 9.7t, so we know t is 2.5, right? So 9.7t plus 0.4. What do you do with this? You plug it in. 9.7 times 2.5 plus 0.04 is 24.65 meters per second. This is precisely why you would find the linear model based on the data. It would be to find predictions of new points, okay? So pretty much you use the information you have, you take that information, you create an equation with it, and this is what people in labs do. This is what people that are scientists, engineers do. They take that equation that they created and they plug in values that they want to find the answer to into that equation, and it spits out hypothetically the correct answer. And like I said, this number can be off by regression of a little bit, okay, but we know it's probably around there. There could be some error, but there probably will not be too much. Good? So, all right. Let's see, where are we going? Whoops. Let's go to the next one. This one. T. Type in your calculator. So, L1 once again is your T. L2 is your hardness. The data in the table shows the Bernal hardness, H, is 0.35. Carbon steel when hardened to a temperature. All right, so when it's this temperature, the hardness changes. As the temperature goes up, the hardness goes down. You're going to type this stuff into your calculator. And now I'm going a little fast, so you can always pause. All right, so I'm typing it in. Oh, wait, I forgot. I'm typing in my calculator. On your TI 88, 89, 90, whatever TIs are up to now. This one's just a simple 84. All right, so I typed it all in. Now I'm going to go to Stat. I'm going to go over to Calc, number 4 Lin Reg, and I get my A is negative 0.3323. Once again, I went to 4 significant figures, plus 612.93333. So I actually went to 4 decimal places. To find the regression coefficient, hit the variance button, go over to number 5, liquid, EQ, statistics, and go to EQ number 7, and you get negative 0.966. So what that means here is you have a negative slope of about 1, right? So every time you a negative slope, your slope is negative 1/3 about. So negative R means the coefficient goes down, and it's pretty strong. 0.99 is a very strong one. So if you squared it, you find the percentage and know it exactly. So what would the hardest be if the temperature is 500? You guys should be able to do this, just as you did before. You use this equation right here. Oh, sorry, 99.3%. So if you squared this, that's pretty strong. That means a lot of points are on the line. What do we got over here? With the equation. Now, if you went to say 3 significant figures here, or you just went to 612 or 613 there, your answer would be slightly different. Like I said, the more decimal places you use, the more accurate it is. So you just got to look to see what it's looking for. Plug 500 in for T, or 46.7833. All right, so you want to round this to about 447. Now let's look. Temperature is 500. 500 is between 400 and 600, right? So the number should be between 495 and 415. It indeed is. There you go. All right, now we're going to take it up a big level here. Data shows per capita energy consumption in billions of BTU. It's the per capita gross national product in thousands of US dollars for several countries in 2004. These are the countries. So you got how much energy they consume, how much money they make off of national products, okay? So pretty much what they say is, well, what do you think? What do you think that means? What do you think happens when you consume more energy? Did you say you should make more national products? Probably. Makes sense, right? All right, so type in your calculator. What's our L1? Yeah, the energy, the national product is dependent on the energy. So you got L1 and L2. So what you're gonna do is you're gonna type them all into your calculator. All right, so stat, edit, and guess what? Look at it, I already typed them all in. Ah, beat you. You guys didn't want to sit and watch me type all this stuff in. So they're all typed in. I checked them all. Everything's good. I got 16 because I counted 16. All my numbers lined up. All my decimals lined up. I hit least squared regression line, StatCalc, Lin Reg, as we did before. Hit calculate, and I get 0.1508x, rounded the 7 up, plus 0.0979. My regression coefficient, vars, 5, EQ number 7, 0.880. Now, the other ones we had were the 9s, right? So what does that mean? What do you think? What happens if I want to find the percent of this? You would square it. So if I squared 0.88, not very good. It's 77.44%. All right? 77% isn't fantastic. So that's like 3/4 of the points. So how can we make this better? We're going to want to make this better, aren't we? Yes? Of course we're going to want to make it better. So, we're going to go to part C. Use the graph, here's still our numbers, to determine which 4 companies differ the most from the rest of the world. The outliers. So I want you to take all these points and I want you to plot them on the graph. Yeah, old school plotting. Right? Sometimes people use computer programs to do this. You're just going to use a pen and paper. So plot all these points. I'll plot them with you. Okay, let me see. 71. Okay, plot. Okay, plot by touching. There you go. I'm plotting as you're plotting. Plotting all the points. Plot the points. All right. All right, keep on plotting. And last one. Nope. All right, so I plot all my points. They look like this. So it doesn't look too terrible, right? I see some points that don't make sense. So now, you're going to go back to, I think it was algebra. I want you to best fit this curve. That means best fit curve is you're going to draw a line that looks like it should go through most of these points. Okay, so just take a straight edge and just move it till it gets to this. Now mine's not long enough, but I believe it should be around here. Boom. Now, I have the numbers 1 through 4 right there. Use the graph to determine which 4 countries differ the most from the rest of the world, your outliers. What an outlier is, in case you guys don't remember, and gals, is it's a point that makes no sense. It's a point where it's data that's no good. Okay, why is the data no good? Well, the data is no good because it doesn't fit what we're doing. That's why you could take the same statistics, get rid of different pieces from the same exact survey, and have 2 different answers. A lot of people do this to cheat. Like they'll say, okay, this drug works good, but they'll just get rid of all the outliers that say it doesn't, or they'll say this drug doesn't work to get rid of the outliers that say it does. It's kind of like a little gray area of statistics, but pretty much you could say most of this data is true, and this doesn't go through for everything. You might come up with an outlier. So we get rid of the 4. So look at those. I want you guys to circle the 4 points that are not good. Did you do it? Well, first one you should have done was United Kingdom. Right there. Okay. That one's a little too high. The one next to it, what's that? That's Hong Kong. Doesn't make much sense. And what these things do is this has actually more per capita income than it has energy used. Okay. It's just because they're richer nations. All right. Number 3. Oh, that looks pretty bad. That's South Korea. So they use a lot more energy than stuff they produce. And this one's really bad. Venezuela. All right. Do you know why they use so much energy? Big oil. All right. So what can we do with those points? What do you think we do with those points? Delete them. Now, does that mean I have to type in my whole entire thing again without these 4 pieces? It does not. What I'm going to do is I'm going to take these 4 points, and I'm going to go, you know what I'm going to do with these 4 points? I'm getting rid of these 4 points. I don't want them. So, in order to get rid of them, I'm going to go, okay, boom, delete. You don't really do. You can put a little X's too. Now, here's what I'm going to do. I'm going to take my calculator. This is key. You got to listen here. You're going to go back into Stat, Edit. Now, I still have my list. I'm going to go down to 167. Okay? And now what you're going to do when you get to 167 is you hit delete. Now, what happens is now the columns don't match up. So I have to go immediately over to 31.43, and I delete that. Next thing, okay, I got to go down to 159. All right, delete that. Go over to 31.56. Make sure you're deleting them both next to each other. Erase that. 186 and 20.53. All right, so I'm going to delete them again. Delete, delete, and then finally 115 and 5.83. All right, now, when you delete all these things, you started with 16, you took 4 away, you should have L equals 12, okay? So that means you have 12 points. So now we got our points, new points. We could find now, move this guy over here for a second. You're gonna hit Stat, Calc, we're gonna find a new linear model. Our new one is 0.1552x plus 0.2240. All right, so that's a new slope that we're going to use, okay? A little similar. Now what we're going to do is we're going to find a new correlation coefficient. Once again, you hit the vars, stat EQ, go down to that, and now it's 0.9843. All right, that gives us a percentage of 97%. So just by erasing those 4 points, I went from like a 77%. I went up 20% better. All right. 98.43. My number's off a little bit. Oh yeah, there it is. When I square that, I get 97%. So just by changing a couple numbers, by taking another couples up, my answer gets a lot more accurate. All right, more accurate answers yield better results. Better results mean you're good. All right. That was a little advanced. This is as advanced as we get. See, 97%. All right, ready to go back to the easy problems? All right, problem number 9. The table represents a set of data points relating to the pressure P and temperature T of a fixed quantity of carbon dioxide in a closed cylinder. find the two lines again. Once again, this is just pretty much using a calculator. So L is your temperature, and your pressure is dependent on what the temperature is. So stat edit, you're going to type in 0, 50, 150, 200. All right, how are we doing here? Almost done. 4, 4.1. All right, least square regression line. Plot these points as you're going. All right, you draw the line if you want. StatCalc lin reg, 0.00936. All right, so just round out the 4, 2.558. All right, regression coefficient. Once again, varus stat EQ, 0.9999, 0.99897. All right, that's about 99.8%. Does that look pretty good right there? It looks pretty good to me. Hopefully it looks pretty good to you as well. Alrighty. Ready for the next one? Yeah. Alright, what would be the pressure at 250 degrees? Well, we know this is the equation that we created. So 250 degrees Celsius, that's a what? That's a temperature. So we're going to type 250 degrees in here, and you solve. 4.908 ATM. Then that's atmospheric pressure, pretty much. What would be the temperature when the pressure is 0? So in this case, you set P equal to 0, and you solve for T. So 0 equals that, so you're going to subtract 2.558 both sides, divide by 94 10,000ths, and you get negative 272.122, which is almost the lowest temperature you can possibly get. Not quite, this close. Got it? All right, let's move on to the next part, the physics applications. Now, way this works pretty much, position represents a blank object without air resistance. What do you think? A falling object. So, in this case, S of t equals 1/2 gt squared plus VOT plus S0. Now this is subscript, so subscript 0. So let's see, what do you think G stands for? It's acceleration due to gravity, and gravity is not negative 10. Negative 32 feet per second. No one uses feet per second though, but Americans, and we don't even use it in engineering. You go to school, you never see the word feet again. It's actually negative 9.81 meters per second. All right. So typically you want to go to 3 significant figures with this to be very accurate. T stands for time. Time's always in seconds. V subscript 0. The subscript 0 means, well, what does V mean? Velocity. So the subscript 0 means initial. So that's your velocity at 0 seconds. That's why it's initial. All right. S. The word S actually means, it comes from the word spatium. Spatium. That stands for height. All right. It's just a Latin word for height. That's why they use S and not H. So that is its. SO would be the initial height, how high your object is to start. And we'll be using this later on in the year. Got it? But this is just so you know what all this stuff is. All right, so now we're going to find a quadratic using a graphing calculator. Now, pretty much what we're going to do is the same exact thing we did before. You clear it all out. Once again, to type in some stuff, you hit stat edit. It gives you your points. We know how to do that already. If you want, you can reset the memory. Okay, remember to do that. You just go reset all RAM, clear it off, reset it after each problem just to make sure. Edit, you're going to type in a couple numbers here. Once again, the same exact beginning as we did with the other problem. Let me slide it, I'm too far away. So, same exact beginning, you just type in a couple stuff, whatever it is. All right, after you type it in, all you're going to do now is to find the least square regression line, StatCalc, instead of hitting 4 lin reg. Since we're finding a quadratic, you go to StatCalc quad reg, which is number 5. Cube reg would be, it's the third power. Quint reg would be, for quint would be to the 4th power. All right, so in this case, there's your equation. Your a is whatever variable goes next to x squared. Your b is not variable, coefficient that goes next to b, x, and then your c is just whatever your coefficient is. Var is 5, EQ, big R squared, which is number 9. That's how you find your coefficient. Graphic is the same way, and so on. Got it? Awesome. Ready to do a problem? You are? Alright. Basketball is dropped from a height of 5 feet. The height of the basketball is recorded 23 times on intervals for about 0.02 seconds. Time. So you're going to type all this stuff into the calculator. So this will take you a while to do. Your time once again is L1. Oh, there you go. And your height is L2. So we just typed this all in. I did it for you already. Alright, you don't want to see me type all this in. This probably takes the longest to type in. So I go through it, I go, okay, let me check to make sure I have enough things. Alright, I should have 23, I believe. Yep, 23 numbers. All my decimals match up, I'm good. Write a model for this. So now you're going to go to StatCalc quadratic. So StatCalc number 5, which is quadratic. Enter through, and you should end up with an equation like this. Your A is negative 15.449. Once again, I just went to 3 decimal places. T squared minus 1.03t plus 5.234. All right, now remember, instead of x's here, I just use t's because that is my dependent variable time. All right, that's it. The hard part is just typing everything in. Oh wait, never mind, I lied. All right, so find the model that will fit this data. So I want to actually find something when s equals 0. I want to know when this hits the ground, and the basketball hits the ground, how long will that take? So what do I do here? When s is 0, so I just plug in 0 for s. Now, how can I solve this equation? How do you solve quadratic equations? You can't just subtract and divide. You have to use the quadratic equation to solve the quadratic equation. A, x squared plus b, x plus c. Oh, that should be b. All right, so I'm going to plug this into this equation. Negative b, so negative that, plus or minus. This squared, this number always becomes positive. A negative and a negative is a positive. So what I would do is I would solve under the radical first. Now, the way to type this in your calculator. The reason I put this up here is a lot of people have trouble with the calculator. You can do this part first. You put your square root. You have to put the negative 1.02 squared in parentheses. But you also have to open up a parentheses for everything under there. That's why you can see there's 2 parentheses here. Parenthesis, the squared, because this becomes positive. Minus 4 times negative 15.449 times 5.234. And the key to this, so you don't get an error, is you have to close the big parentheses in the end. So I end it with 2 parentheses, and then I press enter. Now, this right here becomes 1.302 plus or minus 18.03 divided by 30.9. I'm going to add 18.03 to this. I'm going to subtract 1 point minus that divided by here. And then I'm going to add the 2 together. When I get my 2 answers here, I get 0.541 or negative 6.23. Which one? Only one of these is wrong. Which one do you think? How long do you think it takes? 5.541 seconds or negative 6.26 seconds? Well, time can't be negative, right? So no good. Time has to be positive. Choose the positive solution, 0.541 seconds or 541 thousandths of a second. All right. Good, and let's see, does our answer seem like it would make a little bit of sense? So if we continue this down, yeah, that seems about right. Seems like it would end up a little bit after 0.5. All right, next one, students in the lab. Once again, your x is your independent, and the s is your dependent on your independent. So, did I say that wrong before? I might have said that wrong earlier. Anyway, you're going to type in all these numbers real quick. Student in the lab measures breaking strength S in pounds of wood that's 2 inches thick, X inches high, and 12 inches long. Okay? What is the quadratic regression line? Okay? This is the key. Quadratic regression line. Not linear. So that's the only thing that tells you to do the second type. So what I'm going to do is I'm going to go through and go, okay, type in all my stuff. These numbers are bigger, and as you can see, they don't go up the same amount each time because they go up quadratically. So, edit, calc, quadratic. You should get, calculate, 180.89x squared minus 205.79 plus 272. Regression coefficient, bars, 5 statistics, EQ, big R squared, and you should get 0.9999. Is that pretty accurate? Looks pretty accurate to me. Use the model to approximate the braking strength when the height is 2. So now when you want to find the height is 2, height is x, you're going to take the equation that you created, and you're going to type in 2. When you do that, 180.89 times 2 squared, minus that times 2 plus that is 583.98 pounds. I would do 2 decimals because these are just 2 decimals. Let me see, let me check my answer. 2 is a little bit less, so it should be less than 2,300. It is indeed less than that. Okay. That's it. We really don't know because it's quadratic, it's a squared, so it's not going to be half or a third or stuff like that. It's just going to be less. All right, let's try number 12. We're almost done. We got 2 more problems. So what we're going to do now is find the time t seconds required to attain a speed, s miles an hour, from a standing start of a Honda Accord hybrid as shown. So L1 is your S, L2 is your T. Get in the groove with this yet? Not too tough, right? So what I'm going to do is I'm going to take all this stuff, I'm going to put it in my edit, and I'm going to type it in. 30, 40, 50, 60, 70, 80, 90. So these are the speeds. So when you have the speeds, it takes obviously longer to get the higher speeds. All right, first of all, who wants to drive a Honda? You got to drive a Ford. That's the way to go. Besides that fact, though, we'll check this out. So we're going to type in all our stuff, and then afterwards we're going to type in our quad regression line. So, do you notice any mistakes I made here? Look at, I made that an 8, but I can always go back and just change it to an 80. Don't have to erase everything under. So everything's good. I'm going to hit stat, calc, number 5, which is quad reg, and I calculate it, and we should get 0.002 s squared minus 39,000 plus 1 and 924 thousandths. All right? Good. My regression, bars, 5, which is stat, over twice, down to big R squared, 0.9996. Looks pretty accurate to me. I like it. I don't have to delete anything. How long does it take to accelerate to 10 miles an hour? So, 10 miles an hour is your, what? How long does it take? So we're looking for T. S is 10. So you type in 10. 10 squared is 100. That's 10. And you get 1.734 seconds. Let me go check my answer. 10 is less than 30, so it should be less than 2.5. Looks pretty good to me. All right? And the reason it's a quadratic for something like this is it takes a little bit longer to get your car to 10 miles per hour than it does to get you from 40 to 50. All right? Actually, it takes a shorter amount of time. Yeah, it looks like it takes longer once you get higher speeds to get from between the speeds. Well, this is a stinky car if it takes that long to get up to that speed. Ooh. All right, anyway, let's go last one. 13, last question. Student in the physics labs is studying all this stuff, equations of motion to a falling body. She collects the data that gives the height of the object at a number of times over 0.15 second period of time. She knows that air resistance is negligible and that acceleration due to gravity is always constant, negative 9.81. And then the height of the object of the quadratic function over time t. So she used her physics height equation to solve this. Now, what you're going to do, type in all your stuff. I already typed it in. All right, save some time here. Quadratic regression line, StatCalc. Calc? Yeah, calc. Forgot the L. Number 5, quad reg. Make sure you have your 12. Make sure your decimals are correct here. So when you go to 5 quad reg, you should get A is negative 499 and 1300ths, 73 and 2100ths, and 99 and 200ths. Vars. Stat. Equation. R squared. Enter. 0.999. Alright, if you want to put another 9 in there, you can. It's just to show that's accurate. Right, if this number was like 0.52, probably you messed up plugging in your numbers somewhere. So that's the important thing. That's why we do this, to make sure your chart isn't messed up. Okay, so if this number isn't above 0.9, something in your chart probably went awry. So I would go back and check your chart. All right. Oh, my graph didn't come out here. All right. So this part right here. When will the object strike the ground? Here's our equation. It would strike the ground when your initial, not initial one, h of t equals 0. So as you can see, going to 0. Negative 499.13 t squared. What equation do we have to use? The quadratic form. So type it in, see if you guys remember to do that. Negative b plus or minus b squared minus 4ac. All right. So it's 73.21. Make sure this is in parentheses. When you square it, make sure the whole thing is in parentheses under the radical, and you should get 450.62. So you add the 2 and you subtract the 2. When you subtract the 2, you add the 2, you get 523.83 divided by 2 times a. When you subtract, so your two answers are negative 5.25 seconds and 0.37 seconds. Which one do you think is a better answer? Choose a positive solution, negative bad, 0.37. Now, you may say, wait a second, if I look at this graph and this goes down, it's going to end up at about 0.16, right? But look it, this puts a little break at 75, so it still has 75 more centimeters to go down. So it's going to come here and it's going to keep on going past the chart. So that's why you got to make sure you look at the chart, you see the break there, it's not going down uniformly. And guess what? That is fitting models to data. Data. All right, so we learned how to fit a linear model and a data model, and you learned how to use a graphing calculator. All right, so hopefully you get all this. And if you don't, go back, practice it. Hardest thing is making sure you type everything in the calculator correctly. All right, so say goodbye to Tiger. Until next time, next lesson. See you later.